I want to reference the last part of the chapter, and that is a quiz. So a quiz that I have planned for Thursday this week. Okay. When you look at that, maybe I should reference that right now. That quiz that I have set up for Thursday, predicting the products of redox reactions. Here's one of the things that it says. It says here, liquid mercury is added to concentrated nitric acid, period. I'm gonna, at this point, I want to write the products, the reactants and the products. So I'm not giving you a redox product. You are going to determine the products of the redox reaction. Now with this quiz, you'll notice it says give the reactants, write the products. Do you notice that in the directions it doesn't say balance the reaction? You don't need to balance any of these. So we already did. That's what today's quiz is on, balancing redox reactions. So this quiz is only on determining products. So you do not need to worry about balancing any of these for the quiz on Thursday. So when you look at all of them, you know, a solution of potassium dichromate is added to an acidified solution of iron 2 chloride. When you look at these questions, it can be daunting. I mean, how do you come up with the products when we haven't even seen how to do that yet? How do you know where those products come from? So that's where it seems like a good place to go back to our book and back to chapter 6 of that book. And let me show you where we're at. So we are at, make this, kind of flip through your booklet. So we are at chapter 6, writing the products of redox reaction. So if you have the reaction prediction booklet, you can get it out. If you don't, that's okay. We'll just reference it here. So we're going to look at chapter 6 of that black binder. I think that's what all of them are. And we've already gone through balancing redox reactions. So we are through page 122, 123, 124, 125, 126, 127. There we are. So we are all the way to page 128 in that book. So I want to start on page 128, and I want to figure out for us, how do we balance the products of a redox reaction? So it does say in here, predicting the products is not an easy task. To predict the products of redox reactions, you must look at the reagents given to see if there are available oxidizing and reducing agents. Reducing agent, so oxidizing agent, the thing that's being produced, gaining electrons. Reducing agent, something that's being oxidized, or losing electrons. What a loser. It must be remembered that electrons are transferred so that the oxidation numbers of at least 2 elements must change. Single replacement reactions and some decompositions also fit this bill, but we won't see any of them. If in the problem we see the reaction, say, in an acidic or in a basic solution, that is your hint that this is a redox reaction, where most likely hydrogen ions, H plus or H3O plus, hydroxide ions, OH minus, and water should be included in the appropriate position of the reaction. Remember that acids and bases will also be included in the reactant. Spectator ions will be removed. And then in order to do this, it says, in order to recognize both oxidizing and reducing agents, I have a table for you that would be memorized in a normal year, but for us, it'll just be used as a point of reference. And so, I think I heard someone come in. Someone's in there. Okay. So on page, that's 129 or so, we have the list of common oxidizing and reducing agents. And so we're going to be referring to these quite a bit. So when it says common oxidizing agents, these are things that are being reduced. Common reducing agents, these are things that are being oxidized. So the first one's pretty simple: permanganate in an acidic solution, manganese dioxide in an acidic solution. Where it gets a little bit tricky is when it says free halogen and halide. Some people don't know what that means, and it makes sense that you could be a little confused on that. Free halogen means like like Cl2, Br2, so group 7, that's a diatomic, free halogen. When it says it goes to halide, so that would mean like chlorine goes to chloride, fluorine goes to fluoride, bromine goes to bromide. That's what it means by that. When you come down here and it says there's a halate, some down where it says halate, there it is. All the way down where it says free halogen, dilute in basic, goes to hypohalite ions. Hypohalite would be like hypochlorite. That's what that means. And then you'll see another one there that says halate. That means like chlorate. Okay, and we're going to keep referencing these. This is essentially everything we're doing for the next few days. So here's the first question. It says, a solution of tin 2 chloride is added to an acidified solution of potassium permanganate. Okay. So as I go through this, a solution of tin 2 chloride. Well, tin 2 chloride, so if I think about it, tin 2 chloride, the chloride is going to be my spectator ion. Now that can be tricky because how do I know what's the spectator and what's not the spectator? So if I kind of think this through, let me go up to here, kind of find my page I can write on. Perfect. If it says a solution of tin 2 chloride, a solution of tin 2 chloride is Sn plus 2 and 2 Cl minuses. And when it's added to an acidified solution, my things right here. What does it say? An acidified solution, right?
Yeah.
Right. Acidified just means H plus. So anytime I hear acidified, I'm going to replace that with H plus. And so it says an acidified solution of, what was the rest?
Potassium.
Potassium permanganate. That's a solution. Okay. Now, I have to go back to my list. And when you go back to the list, you will see permanganate in an acidic solution. You will see that this is a common oxidizing agent or something that is reduced. So if this is going to be reduced, permanganate goes to Mn plus 2. So now I think to myself, what else is left? If this is the thing that is reduced, I have to have something that is oxidized. Now let's think. What do metals tend to do? Metals tend to lose electrons. Metals tend to lose electrons. That's oxidized. That's why I'm not even considering these spectators. When you have potassium, alkali metal, when you have chlorine, chlorine will only be involved if there isn't something else there to be involved. So let's say that there wasn't any tin, well then chlorine would be involved, but there is. So because the tin is there, tin is more likely to be oxidized than chlorine is. Chlorine's a nonmetal, it would like to gain electrons more likely. So what am I left with? A solution of tin 2 chloride is acidified in potassium permanganate. There it is. And so what do I get? Well, permanganate, if you go back to that list, so let me find my list here. Oops. If we look at the very first part of the list, permanganate in acidic solution goes to Mn plus 2, right? Goes to Mn plus 2. There's my permanganate. Now again, this is your reduction. Tin, I wrote plus, it's plus 2. Tin has two options. You can have tin go to tin plus 4 or tin metal. Now to go to plus 4, you have to lose 2 electrons, oxidized. To go to 0, you have to gain 2 electrons, reduced. Well, again, as we mentioned, manganese is reduced. Tin has to be oxidized, so it goes to tin plus 4. Now, remember, I'm not balancing it. We've already done balancing. I'm assuming you can do that. I've accounted for the tin. It goes to tin plus 4. I've accounted for the manganese. It goes to manganese plus 2. What haven't I accounted for yet? Hydrogen and guess what they make? H2O. There are some people that there is one product that they can always get, water. The majority of these reactions will always have water in them. Okay, what's the next one say?
The solution of potassium
Okay, so a solution of potassium iodide. Potassium, alkali metal, right? Spectator ion, iodide. Okay, solution of potassium iodide.
Added to acidified.
Okay, acidified, H plus. And so as I go through this, this is what I do. I kind of stop at everything. Next.
Potassium dichromate.
Okay, potassium, that's one of my spectators, so dichromate. There are my reactants. I then go to my list here, and I see that dichromate in an acidic solution makes Cr plus 3. So back to here, Cr plus 3. Iodide, what does iodide do? Let's see. So now I have something that's reduced. So I come down to here. You see what the first one says? Halide, that's iodide, goes to halogen. Halogen would be I2. Halide goes to halogen. What's the only thing left I have to account for? H2O. H2O. Okay, let's move on to the next one here. I'm going to get mine out here too, so I'm making sure that I'm kind of on the same path with you. So the next one here was, does it say the hydrogen peroxide is added to a solution of iron 2 sulfate? Okay, hydrogen peroxide, H2O2, is added to a solution of iron 2 sulfate. See if I have anything on here. Peroxide. Anything with peroxide. Anything with peroxide. Oh, here it is. Very last one in the oxidizing agents. Peroxide goes to O2. Okay. So peroxide, O2. Now remember, it's peroxide. This is the oxygen being reduced. Well, if the oxygen is being reduced, iron must be oxidized. That means it gets more positive. Is there a more positive form of iron? Buster? One last question. Have I accounted for every element? What am I missing? Water. And that's how I'm going to go through every one of these. So let's go through and start looking at some other ones. So kind of go down on my list. Mm-hmm. So where are we looking at here? Isn't this though the dichromate is so you go back. Whoops, sorry about that. This is so the dichromate is what's reduced.
Oh no, I didn't see that.
Yeah, the dichromate is reduced. The iodine is oxidized. Okay, so yep, that's the agent. So then when I go down, we finish these, some other just common reactions, and I'm going to point out the ones that are really important. And I say that because they're the ones you see a lot of. Hydrogen reacts with the metallic oxide to produce the metallic element in water. Well, that's just a single replacement reaction. We actually had one of those last week in our reaction predictions. A metal sulfide reacts with oxygen to produce the metallic oxide and sulfur dioxide. We had this 2 weeks ago in our reactions. Chlorine reacts with dilute sodium hydroxide to produce sodium hypochlorite, sodium chloride, and water. If there's one to put a star by, it's this one. Now, why do I say that? Because you're going to see this again. No doubt in my mind. Hint, hint, right? You are going to see this again. Chlorine reacts with dilute sodium hydroxide to produce sodium hypochlorite. Do you know what sodium hypochlorite is? Well, no, what it is, like common, it's bleach. So this is the process for making bleach. You take chlorine and you bubble it through dilute sodium hydroxide, and one of your products is sodium hypochlorite, bleach, and that's how we get that. Okay, and the sodium chloride water. That's the one we're definitely going to see. Copper reacts with concentrated sulfuric acid to produce copper 2 sulfate, sulfur dioxide, and water. Copper reacts with dilute nitric acid to produce copper 2 nitrate, nitrogen monoxide, and water. And the last one here. Copper reacts with concentrated nitric acid to produce copper 2 nitrate, nitrogen dioxide, and water. Whoa, wait a second. What did we do in the lab this week? What was the first reaction? What did we add the copper wire to? Remember what I poured over the copper wire in the hood? The nitric acid. This is the reaction for your lab. How about that? Who would have thought, right? Cool. Okay, so let's start doing these one at a time. So I think maybe the best thing to do, I will just write over top of this. How about that? And so if you want to keep reference to that chart, we can do that as well. Potassium permanganate solution is added to concentrated hydrochloric acid. Okay, I think I can figure these out. So it says potassium permanganate, and this is what's the key, solution. The fact that it says solution, what can I do with the potassium? Just throw it away. I don't even need it. It's a spectator. So I just write the permanganate, MnO4 minus. If you're wondering, man, these are hard. After we do the next 40 of them, and we will do about 40 of them between today and tomorrow, they will get a lot easier. And the reason I say that is because they are pretty much the same things over and over and over again. So potassium permanganate is added to concentrated hydrochloric acid. So hydrochloric acid, strong acid, H plus and Cl minus. Now, if you're wondering, why did you include the Cl there, but you didn't include it in the other one? Well, here's why. In the other one, remember I had like a metal in the reaction? I don't remember what the metal, I think it was iron or something else. There was a metal there, right? There's nothing else there. We only have hydrogen, and we need another element for the oxidation. Okay, if I go to that list, the list of the oxidizing and reducing agents, I think it's the very first one. It says permanganate goes to Mn plus 2. And then the first one in the next column down says halides go to 3 halogens, that's Cl2. And then the last product must be water. It's just like fitting a puzzle together. Some people would say this is fun. Those same people might be crazy, but they do say that it's fun at least. Potassium dichromate solution. So what part of this is the only part I need? The dichromate, Cr2O7 minus 2, is added to and acidified. So acidified means hydrogen ions. Solution of sodium sulfite, sulfite is SO3 minus 2. And so I take that first part, the dichromate. Dichromate goes to the Cr plus 3. H is there, and I wanted to see this real quick. Oh, there it is. Yes, it is. So the 1, 2, the third line down. In the third line down of your reducing agents, does it say something about sulfite? Mm-hmm. Sulfite goes to sulfate. And then my final product, water. Correct. Solutions of, so that means what do I need to do with the potassiums? Just ignore them. Solutions of potassium iodide and potassium iodate and dilute sulfuric acid are mixed. Now, can you think of why the dilute sulfuric acid is there? What word does it replace in number 1 and 2? The acidified. Now, if it were concentrated, if I go back to my chart here, if it were concentrated sulfuric acid, there is something about hot concentrated sulfuric acid, but this is diluted. And so now what I'm looking at is iodide and iodate. So let's see here. Are there any things in the top? So I go up to the top, and I'm just looking to see if I see any iodides or iodates. So see any eights, any halates.
And you don't even write the sulfuric part.
Nope, I just write the H because it's not going to do anything. So let's see. I have the halides. I wonder if there's any 8s that I needed to write up here. I just want to make sure before I just give you the answer. Because I see one that says basic, and it's not that. Halide, free halogen. I have that. Okay. I don't really know that there's much here that I can go from. So we talked about this earlier. The ide one's easy. It goes to I2. Halides go to halogens. That's pretty common to see all the time. But what do the 8s go to? Well, you're going to find they do the same thing. They go to halogens as well. So as we see these, you'll become more familiar with them. The iodide goes to iodine. The iodate goes to iodine. Because if you go back to that chart, the only place you see a halate is kind of, it's the product of the free halogen in a concentrated basic solution, but you actually get a free halogen with this reaction anyway. Any idea what the other product is? Water. I think somehow, like when I did that video and I showed you that chart of those common reducing agents, that reaction, I believe, of the halate goes to the halogen is in there. But again, we're going to see this over and over again, so we should become more familiar with it. Okay, the next one says a solution of tin 2 sulfate is added to a solution of iron 2 sulfate. Okay. Any idea what the reactant should be? Tin 2 and then iron plus 2, right? No acidified, none of that. So now we have a little bit of an issue. So we have tin plus 2 can go to tin or tin plus 4. Now to go to tin plus 2, it would be reduced. To go to tin plus 4, it would be oxidized. You have iron plus 2. It can go to iron, reduced, or it can go to iron plus 3, oxidized. So how do I know which one it does? How do I know if it's oxidized or it's reduced? So here's how I have to figure that out. We go back to, let me find my things here. We go back to those reduction potentials. I'm trying to think of where mine are. So we go back to those reduction potentials. Let me grab one of those reduction potentials. I know I have them here somewhere. You think of where my reduction potentials are just before. I don't think I put any of them in your, oh, they are in your booklet. You know what? They are. Let me go to where we were. Let me show you this. So I'll go a little further. And here are our lists of reduction potentials. So here's what I'm going to do for these reduction potentials. I'm going to look for, so they're written in the form of reduction. So as I mentioned before, those things at the top, the more positive they are more likely to be reduced. And then at the bottom, they're more likely to be oxidized. So I'm looking for iron plus 2 or SN plus 2. So let me go down here. I found SN plus 2. Let me see, was iron plus 2 here, or do I have to keep going down? Wait, let me see. There's plus 3. So here, let me go down a little further. Maybe I'm not far enough down. Okay, I think that now I'm far enough. So tin plus 2 is right here. Iron plus 2 is right here. Do you notice that tin is higher than iron? That means it's easier to reduce tin, negative 0.14, than it is iron, negative 0.44. Those are what are called electron volts. So the fact that tin is higher means that tin will be reduced. If iron isn't reduced, it's oxidized. So I go back. I should probably have actually scrolled back to where I was before. Hold on. Let me do that. Now that I have that, go back to my things here. I think we're ready here. Oh, that wasn't far enough. Hold on. Darn bell's going to ring here any minute. So what that means is if the tin is going to be reduced, that means my product will be SN. If the iron is going to be oxidized, Fe plus 3. How about that? So hey, tomorrow we will finish all of these. We'll go on to the next one. And then I have a fun sheet for everyone to do on these as well. A lot of these are the same over and over again, but I think it's sometimes valuable to see the same problems, and then you can do those final ones. Okay, sorry about the issue with the link. We'll continue to work on that. I'll get that up today sometime, hopefully working better.
Can you re-explain the iodate?
Yeah, so it's one of those things that we're going to find that iodates just go to iodines. Like the 8s go to the free metal halogen. Like chlorate will go to chlorine. Bromate will go to bromine, and so forth.
Because I saw in the ones that were oxidized, the products it said a halate, and then in the reactant it said a free halogen.
Right.
So you just reversed it.
Yeah, I just reversed them.